Percubaan 1, 2, 3, 4, 5, 6, 7, 8.
Now in this lecture we will talk about standard differential equation of LTI systems. First I will give you one example, and after this example we will find out the general equation. We will take the help of this example and we will find out the general equation. In this example, this black box is representing one LTI system. The input to this LTI system is xt and the output is yt. This LTI system is having one differential equation, and the differential equation is having two different parts. The first part is having the output yt and its derivatives, and I will write down the first part on the left hand side. The first term is 7 times the third derivative of output yt, the third derivative of output yt with respect to time t. Then the second term is 4 times the second derivative of output yt. After this we have 1 time the first derivative of output yt, dyt dt. After this we have the output yt itself. So we are done with the left hand side of the equation. Now we will move to the right hand side. On the right hand side we have the input xt and its derivatives. So in this equation we have 2 times the first derivative of input xt plus the input xt itself. So this is the equation for this LTI system, and here you can see we have coefficients, this 7, 4, 1 and 1 here, 2 and again 1 here are the coefficients, and all the coefficients are constant. So in our general equation we need to have all the coefficients as constant. This is one important point. So now we will move to the general equation. We will move to the general equation. In this general equation, first we will talk about the coefficients. I will consider small letter a for representing the coefficients on the left hand side, and as we are obtaining the general equation we need to consider all the possible cases. So we will have the representation like this: a sub n to a sub 0. An is the nth coefficient. For example, in this case the n is equal to 3. The number of times you are performing the differentiation is equal to the n. So here we are performing the differentiation 3 times, therefore 7, this 7 here is represented by a sub 3. In the same way, this 4 here is represented by a sub 2 because we are performing the differentiation 2 times. This 1 here is represented by a sub 1, and here we are not performing any differentiation, so this 1 here is represented by a sub 0. In the same way, we will have the representations for the coefficients on the right hand side, and this time I will choose letter B. So we have Bn to B0, and if you see the example, this 2 here is represented by B sub 1 because we are performing the differentiation of input 1 time, and this 1 here is represented by B sub 0 because we are not performing any differentiation here. It is simply the input xt. You can see one thing here: n is equal to 3 on the left hand side, and here n is equal to 1. So it is not important to have the same type of pattern on the left hand side and also on the right hand side. So instead of n we will write m. Instead of n we will write m. So we have bm to b0, and here m is equal to 1. M is equal to 1. So we now understand what are coefficients and how to represent them in general equation. and all the coefficients an to a0 and bm to b0 should be constant. If they are not constant, then the equation will belong to time variant system. Now we will focus on derivatives. On the left hand side we have the derivatives of output yt, and on the right hand side we have the derivatives of input xt. Along with the derivatives we may have the output yt also, and here along with the derivatives we may have the input xt. So let's write down the general equation. We have an, which is the coefficient, multiplied to the nth derivative of output yt, plus the preceding term will be an minus 1, the n minus 1 times derivative of output yt, plus all the way to output yt, and here the coefficient will be a sub 0. Now we will write down the right side of the equation. Here we have the derivatives of input xt and input xt. The coefficients will be bm, the m time derivative of input xt, plus the preceding term will be bm minus 1 and the m minus 1 times derivative of input xt all the way to b0 xt. So this is the general equation, and there are two conditions along with this equation. The first condition is all the coefficients must be constant. So this one here is the first condition. All the coefficients should be constant, and when this happens we can say that the given system is time invariant system. So the first condition is for time invariancy. The second condition is very easy. We have already discussed about this condition. All the initial conditions should be 0. I will write down the condition here. All the initial conditions should be equal to 0. This is the second condition, and when this happens we can say that the given LTI system is linear system. So for linearity this condition is important, and for time invariancy this condition is important. And after this we will move to the equation I have written here. Equation should match with this equation I have written here, in which an minus 1 all the way to a0 and bm minus 1 all the way to b0 are the coefficients which are constant. So in examination, whenever you have the differential equation of LTI system given, simply match the equation with the standard equation written here, and also look for the initial conditions. If the initial conditions are not given, then assume initial conditions are 0. This is one important point. If they are not talking about initial conditions, then assume them to be 0. This means the given system is linear, and obviously if this equation is matching to the given equation, the coefficients are constant. So you can say that the given equation is the equation of an LTI system. So I hope this point is clear to you. Now we will move to the questions. In the first question, in the question number 1, the differential equation is given. It is equal to twice of second derivative of output yt plus thrice of first derivative of output yt plus 4yt equal to xt. So you can clearly see here the equation is matching with our standard equation. So we can say that the given differential equation is an equation of LTI system. You can check it step by step. You can see all the coefficients. The coefficient here is 4 and the coefficient here is 1. So all the coefficients are constant. They are not depending on time. This coefficient is A2. This one here is A1. This one here is A0, and this one here is B0. So all the coefficients present in the equation are constant. So definitely this system is time invariant. And you can also see the initial condition is not given. This means the initial conditions are equal to 0 and the equation is matching to the above standard equation. This means it is linear in nature. So overall we have linear time invariant system. So this is the answer of the first question. Now we will move to the question number 2. In question number 2 we have 2 times first derivative of output, but there is whole square. So 2 times whole square of first derivative of output yt plus yt equal to xt. So the coefficients are definitely constant here. Again the coefficient is 2, the coefficient is 1, here also the coefficient is 1. So coefficients are constant, but here the equation is not matching to the above standard equation. We don't have the square of the derivatives, but here we have the square of the derivatives. So definitely the system is time invariant, but it is non-linear. So it is not a LTI system. Now we will move to the third question. The third question is the last question. In this question we have 2 times the second derivative of output yt plus 2t times the first derivative of output yt equal to the first derivative of input xt plus twice of xt. Our first step is to check whether the coefficients are constant or not, and if you see the first coefficient, it is constant, a2 is constant. Here this is a1 and it is not constant, it is equal to 2t, and 2t means it is depending on time. Whenever there is change in time, the coefficient will also change. So this particular equation is not for time invariant system, it is for time varying system, but definitely the given equation is for linear system. So overall we don't have the linear time invariant system. So whenever you find any one coefficient is not constant, there is no need to check further. The given equation is not for LTI system. So I will repeat the conclusion. The differential equation will be given in the problem. Look for the initial conditions. If initial conditions are not given, assume them equal to 0. This means because of initial conditions not given in the problem, we don't have the non-linearity. We can focus on our equation, and whenever the initial conditions are given and they are not equal to 0, there is no need to check the equation given, because non-zero initial conditions will make your system non-linear. So this is the first thing you need to do. After this, you need to check whether the given equation is matching to the standard equation or not. And the step number 1 is to check the coefficients. All the coefficients in the equation should be constant. If they are constant, this means the given equation is time invariant. Then look for the derivatives. The derivatives should not have any non-linear operators operating on them. Like in example number 2, we saw this is square operator operating on the derivative of output yt. So whenever such operators are operating, this means the system is non-linear. So this is the complete process, and I hope you now understand how to check the given equation is for LTI system or not. So this is all for this lecture. If you have any doubt, you may ask in the comment section. From the next lecture, we will start the Fourier series, and the remaining questions of LTI systems we will solve in discrete time part and after completion of Fourier transform and Laplace transform. So this is all. See you in the next one.
Okay, Assalamualaikum. Hi everyone. So I hope all of you already done view the previous video, which is the some basic knowledge on the LTI system, which is the linear time invariant. So I think all of you already know what is the LTI, what is the function of the differential function for the LTI system, how the basic, how it's work. where the input and where the output. Okay, so we continue. So okay, so according this first question, not first question, but the first equation here. So the first equation, I think it is same with the basic for differential equation, but for this one in the lecture note, we use the k, and the previous video we were using the n. Okay, n and m. So I think it is same here. The n here, which is the number of derivative, and for the left side, for the yt, which is the output, and for the input, the k is the number of derivative. Okay, this is the a and b. So make sure you remember the two condition of the LTI system. For the first one, which is the constant, coefficient must be constant, and the second one is the linear system. So the both condition can measure the system is in LTI, so which is the linear time invariant. Okay, so according this one, okay, we look for the step one. So you can substitute here, the yt is equal to exponent xt hs. So according this one, the n, or the coefficient, which is a, is time to the hs. Okay, so how to find hs? So the value of b here, the coefficient b, is divided to uh, to coefficient a. So this is the step 2. I think all of you already done for the tutorial, which is I think the number 3 for the differential equation system. So make sure you don't misunderstand. Okay, so the b, which is the input, xt, must is must divided with the coefficient a. So this is the final equation for the HF. Okay. Okay. So we look at the example 4.7, which is the find the transfer function. Find the transfer function of the LTI system described by the differential equation below. So according this one is 1 times to the second derivative of yt plus t3 times first derivative plus 2yt, okay, plus with 2yt equal to 2 the first derivative of xt minus with 3. Okay, according this one, you still remember the LTI system, the coefficient must be constant, and it is a linear system. Okay, according this one, so how to solve this one? So you just follow back which is what is the b and what is the a. So you can get the final answer is 2s minus 3 over s power of 2 plus 3s plus 2. Okay, you got it? If it is simple, so s power of 2 means for the second derivative, s means the first derivative, and 2 is the we can refer back which is the sub for the sub 0. Okay, same for the value of x, and this is the value of y. Okay, it is easy, right? So I think that's all for the transfer function. I hope all of you can understand, and I hope all of you can score my question here for the next quiz and for the next test. I hope so. I can give you this question for the test. I hope all of you can score, and good luck for the next topic. Okay, goodbye.